Okay, so this is gonna be a quick one. So I purchased some new wire. Okay. So I bought some 22 gauge stranded wire. You can see here. Let's see. Unfortunately, this thing doesn't autofocus, which honestly, in some circumstances, is great. But anyways, it's much more bendy, and I cut it short because I just want this to be a very compact, small testing thing. Anyways, so we just need to cut a bunch of these. So we need 8 of them because we're starting over. I know we did this uh yesterday, but that was with bad. Oh my god. Ay ay ay. I think there's something about you can't take too much pleasure in this bullshit because then you think your whole life is just doing this menial repetitive manipulation of atoms, but it's like no, I want to do something that's never been done before. Everyone's done this thing, this fucking DuPont connector thing. It's not like it's special. So recording it is just not useful. The only reason why I record it is okay. I don't know. Is that enough? 1, 2, 3, 4, 5, 6, 7. Thought I had one extra. 8. Okay. So let's get to stripping. You know me, crimp walking family. I'm so bad at making sure my hands are in the shot. Okay. So now we do this thing repetitively. We take our crimp tool. You gotta twist it up. I think I might have messed this one up. I can't really tell. It's kind of a gamble. So wait, so let's look at the chip here. So the chip has the two middle pins, and what is it? Clock is yellow? I always forget. Let's just send it. It doesn't really matter. Yeah, where was that testing one that I had? I did this one with red, and I got it like just right. I think I pushed it in too far. Let me do another one. Twist it up. That one looks pretty good. Okay, so this is gonna be on the 3, and it's gonna be like this. I thought there's 2 clicks. Okay, wait, we need our little test. So we have our stepper motor that has a pin on it. Seems fine. Alright, so let's do the black one then. Nice. Okay. There we go. I heard the second click on this one. I think this one's almost there, but not really. Look at that. That's pretty nice. We can do our test in a minute. Okay. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 1 Nice. Alright, I'll probably redo the yellow one because the yellow one is pretty fucked. Okay. Yeah, so when you do this, you need to make sure that it snaps twice. It makes two very faint clicks, and it's the second one that really locks it in. Mm. Oh no. I might have fucked this one. We'll see. Damn it. I'm so bad at this, dude. Alright, whatever. We have to just cut this off. Obviously, on the last one, I fuck it up. Okay, whatever. Okay. I think it'll be fine. Damn, what? God, these DuPont connectors are gonna be the death of me. See if we test this though. doesn't make a connection. I can't tell why. Can't tell why it's messed up though. Maybe we should just do it with ones and zip tie it together. 4 is obviously the best, but it's like I just don't get it reliably enough. See, that first click, you're like, oh yeah, I got it, but you really don't. Damn. I really don't understand. Let's see, like, what is preventing it from going further forward? Like, what was it about this one that was so good? This is perfect on both sides. They make it look so easy, but it's not easy. Not easy at all. Okay. Um. All right, I'm gonna try to just do it with ones. What is wrong? What is it that you have to do to get it to go that tiny bit more? Is it that I pulled it back and that it's not? Curse these, man. Curse these. These are so hard to work with. Fuck. Okay. Just gotta keep trying. I feel like. Alright, I feel like. Alright, I gotta just start changing things around. First thing is. Alright, so we gotta cut some more of these off. Is I'm gonna just. Okay, I think I'm going to just. And not crimp down the other one. All right, so I'm just gonna. These are just gonna be tests. So I'm just gonna cut this off because this is bad. All right, twist it up. We're only gonna do one, and I'm not gonna. I'm only gonna go down 2 clicks. Okay, I'm gonna strip some, and I'm gonna get uh the voltmeter. Almost assuredly, this thing is gonna make electrical contact. Okay, wired up. Turn it to sound. Cool. Okay. All right. So the test is. Let's see if that made any improvement. Please, please, please. 1 click. Oh, here it's actually too big. So you do need to crimp it down that second time. What if I just try to squeeze it? God, this is such a headache, bro. Alright, so we're gonna crimp it down the second time. But then that means that we changed literally no variables regarding how we... So then it's just a luck of the draw sort of thing. Let's see if it fits in there now. I'm gonna go back to the video. And why you shouldn't.
This is a crimper. These are DuPont terminals. The pitch is 2.54 millimeters, and the wires coming by in a ribbon like this are 28 AWG, 28 gauge wires. This looks intimidating, but it's really easy to make these crimpers. Pay attention to that shelf there. If you grab your wires and you remove housing, you'll see this kind of assembly. And you can see right around here is where the conductor cover stops, and right around here is where the insulation stops. Make your life easy by using the female terminal on the wire and the male terminals on the board. That means we're going to crimp with the female. Before you use this tool, you should be asking yourself, for the love of God, do I really need this? Because parts like this come off the shelf in many different lengths. Parts like this offer you extensions for the most common actuators, like the Futaba style servos. This is the same crimp, by the way. If you're doing extremely quick and dirty prototyping and you're still using that solid breadboard stuff, just keep in mind that the 22 wire gauge single cord wire can do the job to offer you the male connections. These are nice 22K, regular school. You need to come here, you can use 22 stripper, and you're going to get the same contact that's effective in plugging into these front connectors. Why do I recommend the female to always go on the wire? Here's why. Your board is the element that you have control of. You can fasten that down to a piece of plastic foam. The wires are the part that sling around. That means if you have male ends on wires, you are just waiting for an opportunity to accidentally fry your components. Okay, you absolutely must have a difficult life, then proceed to take 3 or 4 millimeters off of your insulation. Grab your crimpers, find that shelf at the top, and then hang up the wings on the shelf. You're going to pull it towards you until it hangs up, and then you're going to go click, click, until it holds. Now, with the worst case scenario, you have some cheap wire that has approximately 30-something gauge that's advertised as 28. Feed it in just so that the insulation comes out to the wings. Can't see too well. And then go for it. You're going to get 2 crimps. The long wings grab onto the insulation, and the short wings grab onto the copper. Now we're going to put the housing on. What? No, never do that. Grab a housing with the number of contacts that you need, not individual houses. You will not have mechanical integrity if you plug in your stuff to individual housings. And we're going to push. Look, this one wasn't that great example. This happens all too often. These wings get hung up on the back of the housing. You don't push it all the way in, but maybe you think that you have. You do the tug test, and it kind of gets stuck in there. So, my goodness, here's the solution. Okay, grab a pointy object. And take a look at these wires. You should have just said, wow, I really chose a difficult path. Okay, back here. Go ahead. Insert, first push. You're going to make a tiny clearance. You're going to insert the blade and lift. This is best. It's anchored on the table. Then slide it out. Now you're going to ask yourself, what's wrong with this thing? All right, these wings are still too wide. And the crimper couldn't do its job tightly enough this time around. So we can squeeze these guys just enough. Maybe even do top bottom. Because that whole thing has to fit inside the housing. It's really hard to have the right camera.
This is a better video, actually.
The air wings around, so we put it in here. You hear that tube clicks. The second click puts us.
Oh. I fucking hate this, bro. These fucking connectors are ass, man. Alright, you know what? Where did I put that row of them? I feel like we're just gonna, cause I'm pretty sick of this thing already. Alright, let's... This shit is so fucking crazy. Okay. And why you shouldn't. Yeah. I hate these. Deep Purple 1337. Guys, go check out my channel, Deep Purple 1337. Alright. So I've done this successfully twice now, is I guess what the point is. All right, so let's yeah, I do. I need an X-Acto knife or a blade or something. Okay, I got it. Don't tell me I got it. Okay, so um I feel like it's not doing anything. God, what a nightmare. What a good video though. Oh, that's this guy? I've seen that video recommended to me. Oh, there we go. Okay. All right. So we did it. All right. All right. So you just have to be extra careful. All right. So I'm ready to continue. We're going to take this. Oh wait, did we shorten it? Damn, I want it to be exactly right though. In any case, we can always cut it down maybe. Oh my god. Okay, I also realized part of the problem. I'm such a fucking clown. All right, so we're going to just start all over. I'm going to start all over. All right, so the clown move that I made was that I was using the 22, right? I should be using the 26 because the reason why those wings aren't closing is ugh, dude. Ay, 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 bro. Okay. Nah. I have high hopes now. I have high hopes now. Let's see if we can recover any of these connectors. We'll recover the connectors because they should be fine. But I do want to just start all over. And okay, so let's just well, this is usable, and I don't care. I don't give a shit. Okay. I do. I need something sharper. What's a good... Oh, what about my knife? Where's my Leatherman? I'm gonna go get my Leatherman. Fuck it, I'm starting over. I don't care. I can't be bothered with this. Okay, so we need 2 more of these, right? We need 1 more of the 2, or do we still have a 2? Where's the other 2? Here's the other 2. Okay, so we got our nice thin wire. That seems about long enough. It really doesn't have to be that long. Okay. Doop 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 doop. That video is so much better than the other one, dude. It's actually crazy. Because he actually tells you, like, oh, yeah, these things suck. Don't use them. Honestly, though, I will say for the non-wires, if you're just doing the, like, pin headers, it actually worked really well for me. I don't even remember what I did. I gotta find that stream, because it worked really, really well for me in that case. Okay, so let's just get this thing started again. Okay, let's just try one. And then I gotta go eat dinner. Even though I'm not even hungry. I'll eat later, man. I'm not even hungry. Alright. Okay, 2 clicks down. Ugh, so easy to bend them. Alright, be delicate. Oh, wow. Yeah, it is super easy to bend them. Okay, then into the smaller one. Alright, I'm feeling optimistic. So in our chip, I have VCC like that, and we want it to be like this, so then this one needs to be on the bottom. One click, 2 clicks. Alright. Alright. I'm optimistic. I'll just leave it running. Okay. All right. Let's finish this thing. I'm pumped. We got this. This is no big deal at all. Bruvna. Governor. How many do we need? You need 4 more. Okay. All right. Let's do this thing, bro. Wagwan, brother man. Okay. Fuck. Dude, that guy's so right. How to use DuPont and why you shouldn't. Because these suck. Alright. We hope and we pray that it works. Oh, yeah. Alright, so the real message is that you absolutely do need to use the right gauge wire. 22 gauge wire is absolutely too thick, and it's not going to work out for you. Or at least it didn't for me. Alright. We are getting somewhere. Fuck. Dude, these things suck so much. Oh my god. Alright, I'm gonna put it in the freaking meat grinder again. Let's see if we can get this thing to clamp down properly. Please work, please work, please work. Oh, it's like right there. Oh, I got it. Hell yeah. All right. Last one. Let's pray on this one. Let's pray. Let's pray. Okay. Yeah, these connectors are a total nightmare. And you know a robot is just doing them by the millions. In any case, I just gotta get this done. And we'll be all Gucci. Fuck. I knew I made this thing too long. Okay, that looks good. Alright, this is the moment of truth where we're half done with this nonsense. One click, and it's stuck. Wait. Wait, why did it just come out like that? Damn it. Okay, this stuff actually sucks to work with. Why did it just slide out like that? It's not right. Okay, let's just squeeze on it. I'm gonna crimp it again. Let's see. Oh yeah. Check it out. Unfortunately, it's not like the right length. But whatever. It's good enough that we can do this. And now we just need some male pin headers to plug it into here. So this thing is going to have to route under the... Oh, wow. So this thing is going to have to be tall. That's okay. Okay, so... Alright, so we'll figure this out. Let's just do this one and see how it goes. This is one of these things that's hard work and very low reward. Like, it's not rewarding at all to do. Okay. So wait, so how do we want this to go? If it's gonna go like this. SCL clock is yellow, right? So that means that this needs to go on the top. What a joke, man. What a literal joke. Nice. All right. It's starting to get, it's starting to get to the point where I know what to expect. It's not like it's just unexpectedly failing all the time. Which is good. But I totally agree with that guy. Don't do this. It's so stupid. Bum 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 ba boom. Nope, not even close. I don't know why I don't just. All right, I'm just gonna by default start crimping them extra. All right, so you push it in and then you do it with like wire strippers, and then you do this again. I honestly have no idea what it does, but it does help it go in, it seems like. All right. Check it out. Check it out. Should we try some of the male ones? I'm kind of curious. I've never used these ones before. Okay. What a hilarious thing, right? It's like slave labor shit. There we go. Okay. Okay, so squeeze it down, crimp it, son, crimp it. Yeah. Water. Okay, let's try it again. I think that's it. Check it out. That's pretty good. That's not bad. I don't hate that. The reason why I was like, oh, I don't want to buy, or it's not that I don't want to buy. It's that I want the right colors, I guess, at the right lengths. Why do I think it would go in on the first try? It doesn't. It just doesn't go in on the first try. You have to fucking crimp it extra. You gotta crimp it extra. Even then, it doesn't fucking go in. I want to pulverize this thing. I wonder if I can. You know what? I wonder if I can just take these needle nose and pull it through. Literally the last one. Come on, give me a fucking break. All right. Pretty nice though. So what's gonna happen is we're gonna have this stand. This is gonna be sitting on here like this. Yeah, we're just gonna have to make this at least as tall as some of these DuPont connectors plus some. So oh wait, there we go. The connection is weak. How do you eject it? Maybe it's a little corroded. I don't know. Seems like it's fine now. Okay. All right, so let's just make the thing. I mean, at least 25. Okay, so it's time to do some CAD work. I reprinted this plunger. Maybe now is a good time to install this thing. So this was the first design. Is a is just something that clips on. Unfortunately, since I printed it with no supports, the droop made this thing kind of janky. But the other thing that I realized about this that's super badly designed is that we want one of the faces to be level so that it doesn't go past it, so that when you rest it down on it, it's at the normal height. Because I there's a whole bunch of places where I use a specific geometry and the whole height. So if we want to change, we'd have to change all that. But we don't want to actually affect that. Okay, so I think I'm just gonna freaking send it. So we have one of these. Where do we put those magnets? We have. Are these the magnets? I don't know. I'm gonna get the one that I know is definitely one of the magnets. So we need our little piece of cardboard. And then I kind of want some gloves, honestly. I really don't want this stuff on my hands. Alright, so I'm gonna go get some nylon gloves. Actually, I should probably keep a pack in here. Seems like a useful thing. Okay, so we're gonna use this little piece of cardboard and some toothpicks. And I'm gonna go get some gloves. Alright. I know this is overkill, but I just don't want to get my fingers glued together. Okay, so we need to figure out the plan of attack because I really don't want to mess this up. Because if we get glue in the shaft, it's going to be a total nightmare because it's basically going to... So we need to make sure... Well, I think I'm just going to put it... I think I am just going to... Okay, so wait, we need to get the magnet. Where did I put the magnet? Here's the magnet. So we're going to take the magnet and we're going to put it in there. Okay. Then we're going to We're going to uncap this. Fuck. Fuck. Okay. Now we're going to put the drop of super glue on here. Okay. And now we're just going to press it in and hold it in. And I don't know. Hey Google, open ChatGPT. Yeah, obviously gets that wrong. They probably added a special case so that it doesn't recognize that vocab word even though it's all over the place. Fuck. That's crazy, bro. If I had no hands, I would have no access to information right now. I can't control my computer with my voice. I'm literally helpless. Let's hold it up and down. Make sure that... What is the dry time of this Duro super glue? 30 seconds? Seems like it did. Nice. So now there's a magnet there. So when we spin this thing, all right, that was pretty easy. I'm glad that we did that on stream because that was pretty easy. Super glue works wonders. All right, so I'm just gonna put these gloves back because nothing got on them. All right, now it's to design work. All right. Yeah, gloves are a good thing to have. All right. So, we are now designing this, and we are redesigning it so that so we want to figure out what does it look like. So let me look at his. So, dude, why is this thing always on? Curious Scientist PID.
In my previous video regarding this platform, I have already...
But we kind of want the other video, right? Here he goes over the print.
So that's what we have. I was bearing will be actually pushed towards the inside of this plastic stuff in a way.
So yeah, so the reason why I have to redesign it a little bit with the clips is that I can't get my case off. So I can't use those screws. Plus I don't have long enough screws. So
Casing, so it does not stick out. And then I just measured the distance between this magnet and
okay, yeah, so we don't actually need to... Let's look at that print file. I think I downloaded it. Okay. We could... Wait, this gives you an STL, but... Well, we could download this. Right, so all we need to do is take some... Oh, we can't even measure it. Yeah, that's so annoying. So this isn't even... This is why... Bro, this is why I want my Onshape account to look like an Instagram profile, like a social media profile. You can just... Like I could... Or like GitHub. Like GitHub. I don't know why Onshape isn't like GitHub, where you can share your projects. Um... Um... I need something even thinner. Let's use one of these. Oh, fuck, these DuPont things are so weak. Okay. We need like a pin, like a sharp pin. I'll hold it upside down. Yeah, that's one thing that I didn't do. That's really stupid of me. Make sure that it doesn't drip. It seems fine. I think it did get in a little bit, but not the end of the world. Yeah, I don't have any pick like things. It's fine. It'll be fine. Okay, let's just design this thing. So the first thing we need to do is we need to take our calipers and measure from here to there. All right, so we have like exactly 1 millimeter. Okay, so when we go to that's 2. I mean, that's not actually correct. But anyways, we have 1. So if we want a height, what is the optimal height? He has the data sheet somewhere. It's also in here. Let's see. Does he go over the data sheet? He had a really nice picture. There. That's the stupid thing about uploading in 4K is that then you get like a, I don't know. It's a 0.5 to 3. Okay, so let's just get to work.
90 degrees.
Wow, how slow is that? Damn, Firefox's full screen is like really slow. Okay. We are going to go to CAD. And we are going to design something way better than this. Okay, so let's just start off with modeling the AS5600. What am I doing? Rename AS5600. Okay, so now we're gonna get our chip, and we're gonna just measure some dimensions. 1.6. Okay, so Alt T, Alt T. I wish I could just jump to the search. It's so stupid. Why did when I do this, it should just oh my god, dude, Firefox is so bad, but it's the only one that's not gonna literally leak my information every 5 seconds. Streaming is such hard work. I'm in dangerous conditions. Let's see if it knows. I don't know. If I gotta get. It's so narrow. Oh, is this muted? What? Wait, why is it?
Good? How? Ow!
You're good. You're good.
Ow!
You'll be alright.
I love Josh.
Bitch!
Alright.
I hit myself head on
I'm sorry.
A few moments later.
Josh, get it. We'll get to it fast.
Ow! Oh my
Oh,
god!
it feels like
Ow! God damn it! I'll sue this place. Ow!
That's the second time.
Ow! My head hurts.
Good.
Ow!
Watch out for the top.
How can I do it? It's so narrow.
How can I do it? It's so narrow. God, he's so funny, dude. Alright. What the hell is going on here? I can't even edit my variable studio. The world does not look down upon Firefox with... I think it was just laggy. I think the performance was just garbage. Okay, so, okay, yeah, so chip depth. Holy shit. Yeah. What is open that's so lean, maybe? No, that's crazy. Dude. I gotta get a new PC, bro. Should I just send it, dude? It's like my build is like $800. I'm using my old graphics card. I'm getting new RAM. The thing is the case. I need to measure the dimensions of the case. Maybe I'll do that after this. Alright. Let's just get this printed. Oh my gosh. It's actually... It's actually unusable. Okay. Do we have a drawing of this? Maybe there's a drawing online. Whatever. 23. No, this is crazy, bro. Oh my god, it's so slow. I hate Onshape. Okay. Chip to top IC. Let's see. Are we zeroed? Okay. $1.6. Okay. Top of IC. Let me prefix this with... Yeah, wait. So let's change this too. Should I just log into Edge? This is like brutal. Oh, God. Definitely loaded faster. Yeah, dude, wow. That's so funny. Firefox literally is just bad performing. That's funny. Alright, so this also coincidentally was 1.6. So, um, I know I did this before in Fusion, but like totally blanking. So then the distance to the wait, do we have a drawing of this chip? Oh wait, I have to do something. Jesus. Okay, this is okay. Alright, so it's this. Wait, is it this or is it that? They're the same. Oh my god. Oh my gosh. Why are these browsers so insane? I'm almost tempted to use freaking Andreas Kling's nonsense. Just because you know it doesn't at least have he doesn't have the capabilities of completely shitifying. How does that make sense? 17 for 5? That's like a higher unit cost, right? 10 over 3 is 3.33. 17 over. Yeah, it's more. What? That's random. All right. Uh, so we don't have a drawing on this thing? See if we can find a data sheet. Yeah, what's funny is that they name the PCB based off the IC, which in some ways makes sense, but you know, it's kind of weird. Okay. Come on. So let's just CAD that. Okay, so this is going to be the AS5600 sketch. See on there. No. Let's just make it a rectangle. So this is gonna be rectangle here, and then it's gonna be AS5600 width. Ugh, what? Oh my gosh. Oh my gosh. Just do what I say. Just do exactly what I want you to do. Stop being so stupid. Really, cat is so stupid. Okay, so now we need to know. Presumably on here we could get the dimensions of this thing, but I don't really care. I'm just gonna put it in the center. All right, great. So now we're gonna sketch on here. Should we measure this thing? Might as well. It's so unnecessary, but I'm gonna do it. Okay, 5 by 3.8. These do not need to be parameters. So this is going to be 3.8. This is going to, oops. Thank you for thank you. Thank you. Thank you. Alright. Wait, what? How is this not well defined? This just decided to. Oy, oy, oy. It's being so temperamental. AF 5600 top of IC. Okay. Okay, cool. So this is basically it. Now we just need the mounting holes. And so first off, we're gonna measure the diameter of the mounting holes. 3.75. Okay. And then 1.4. Wait, it's a little asymmetrical. One 1.75. 1.6. 1.5. Whatever. I'm so ready to just stop using computers altogether. They're just so stupid. What did I say this was? 3.75. This is continuing to bother me. You really have to do this? I feel like there's got to be a better way than this. Oh wait. Finish the sketch. Circular pattern. Features the pattern. This extrusion. Access the pattern. This stupid thing. Okay, so this is basically what it is. But now, I guess I'm gonna do this too. 2.56. That checks out. Two 2.6. Okay, so what we're gonna do is wait, no, not on there. You need to make a rectangle. Oops. So this is going to be, so wait, let's just get this right. This is symmetrical at the moment, but let's just pick an orientation. So I want it to be like this because this is, so then this side is going to have 3 and this side's going to have 4. Okay, so this is going to be 4 times 2.54. Then this one, 3 times 2.54. Okay, then how do I say that this is in the, it's not on the midpoint of this line. Okay, what you do is you do this. Make a construction line like this. Yeah. Okay. Say it's a construction line. Then you say these are mid-pointed. Wait. Needs a point. Oh yeah. Okay, wait. Is this how you do it? You like this. And then you say that this point and this line are mid-pointed. Are they coincident too? Okay, yes. Now it's this distance. So this. So wait. This width is 2.54, right? Okay. It's so funny because, dude, I'm so ready for the world of code CAD as code because like literally so much of this, if we took the approach of code, the amount of reuse would just go way up. Because like right now, the amount of reuse in CAD is just so freaking low because everyone's just designing the same things over and over and over again, and it's just totally insane. So what did I measure this at? I could do a depth thing. How about that? All right, it's at 0. Let me just go like this. .79. Okay. So now we need to do the same thing here. A line at the midpoint to here, make it construction, dimension it to be 3.8. Then say that this point and this are midpointed. Okay, cool. So now we are just going to make them big old blocks. So 8.3. Okay, so we're just going to take both of these faces and extrude them by 8.3. Okay, so these are going to represent the pins. I mean, all we need to do is we're simply doing this for clearance reasons and interference reasons. I'm not actually trying to model this PCB. That would be crazy. What did I make it? 8.3. Okay. So now the idea is that this is going to feed through basically the just something like this. Do we want to design it so that it can sit upright? I feel like I do want to design it so it can fit upright. Nah, for right now, let's just not. Okay, so we want to go back to this. Wait, not that. First off, this. Can we just delete this? Okay, we want to go back to this, and we want to redesign it so that when you look at this thing, we want three walls to come over. So maybe like God, why is it always the mouse? Why is it always the parts that like I don't want this to take a long time, but it definitely is going to take a long time. What if we just build the simplest thing before we fix it? Because I'm not in the mood. Okay, so how does it mount? Does he mount it with... Okay, so if this goes on there like that... you can make that bottom... Yeah, as long as you... Well, not as long as you want, but... up to 8.3. Well, a little bit less than that. Yeah, so I don't see anything wrong with this. Except in my case, I do need to make it go around the walls. So we basically need to take this, add in this geometry. Okay, so at this moment, if we were to place the... I can't remember how I did it when I actually built this. I'm pretty sure that I couldn't have the... If this is facing up, the chip is facing up, so the motor's pointed up. I couldn't put the bolt going down this way because the socket head was greater than the depth here. Okay, so let me just okay. So we're gonna draw a rectangle, extrude it this way. So now there's a block sticking out of this. Then we're gonna take this and the okay. So let's just try that. So this is going to be like 25 by 25, 25 by 25. Okay, then we're gonna extrude this, and we're gonna make it like, let's see. Now we have to do some math because basically the bottom of this plus 3.2 plus 1. Wait. Okay, so there is the magnet is floating 1 millimeter off of this. We need the distance from this magnet to there to be, let's just say 1.5. Right down the middle. All right, so let's make that a variable. So magnet to, oh my god. Oh, it's because I'm in Firefox. Oh shit. Wait, did that just... So we want, so data sheet recommends 0.5 to 3 millimeters. Okay, so this, we're gonna make this 1.5. So now, if that's the case, you really don't have a lot of room because it's going to be half a millimeter down. Okay, so then, okay, so this needs to be, so we're at 1, 1.5. Oh, we need to add walls. We should probably make it not 25, but like 26. Or maybe 27. But now it's going to be plus 3.2. So we need it. And what's the thickness of this? This is 2. So we're at 0.5, 1.5. So we want 3.2 minus 1.5. Is that right? That his looks way deeper. Am I missing something? No, I think it's actually not that deep. I think his is probably uh okay, so wait. I gotta here's what I'm gonna do. I'm just going to do plane offset, and then this is going to be 1. And then on here we're gonna sketch a circle, and I don't know what it is. It's probably like 5. And then from here, we're going to just extrude, I don't know, like a 3mm little disc. It's its own body. So this is the magnet. Great. It's its own body, but so now we need the distance from here to the top of the thing to be 1mm indented. So let's start off by going back to this sketch. We're going to move this down here. Oh, wait. Wait, what? What? Oh, wait, it was the wrong sketch. I'm talking about this sketch. Okay. So first off, let's just make this 27. Delete. Equal. Okay. And it's centered, right? Okay. Okay, so let's extrude this down by so basically, let me think about this. This extrusion depth. Okay, so right now there's 0.5 between here. And then 1 down. So that's the midpoint here is at 1.5. So this in the middle here is going to be the top of the IC. So from the top of the IC to the bottom of the chip is 3.2. So we need the extrusion to be 2.2. Nice. Okay, then we need a sketch on here. And we're going to make this, we're going to make a rectangle. And it's going to be, 25. And then these two are equal. Then we're going to extrude this down. This is going to be a remove, merge with encoder mount. And it's going to be, oh, but you need some for the wall. Okay, so let's do this. But this extrusion needs to be 2.2 plus, we're going to say AS depth plus AS top of IC minus 1mm plus 3mm. Okay, then we need to do this extrude, and we are going to extrude to the I'm going to take this extrude, we're going to copy everything but the 3. Alright, so now if we were to measure this to here, it should be, it's 5? Dude, we fucked it up? What? How did I mess that up so much? Oh, wait. I think we just need to get rid of the, this is going to say 4, though. That's not right. I'm tweaking, bro! I'm fucking tweaking! Oh, wait. We need to do a +1. I get it. Oh my god. I'm so sick of that. I wish I could just change that feature so that anytime I add, it just defaults to the default units of the workspace. Okay, so now if we take this face, we hide this, and then we take this. Its distance is, oh great, yeah, thanks for not giving me, wait, what just happened? There we go. 5.2. 5.2. What did we say that distance needed to be? Oh my god, I think it's wrong. 5.2 minus that 3.2 is 2. It's because I... Plus, it's... Okay, the thing that's supposed to drive this isn't even driving this. Um... Okay, I don't actually care. This is so, like, not important. So we're just going to take this extrusion and subtract 0.5 millimeters. Okay. Then we're going to take this extrusion and we are going to also subtract awesome. Now take this and this. 4.7 minus 3.2 is 1.5. It's not driving anything, but it's okay, great. So now we just need to copy some of that sketch geometry. So we're just gonna put this in here. Yeah, this is more of a prototyping night. I really don't want to get everything like hammered home. So wait, so let's just start off with this. Okay, so this is gonna be 23. Okay, then we're gonna put circles here, and then this is going to be, what did I say? 3.7. Oh, see, this is why you need to use variables, because otherwise you don't even remember. 3.75. And what did I say for that? So let's just open this up in a new tab. Which sketch is it? Just click on this. Sketch. Why aren't there any... Oh yeah, because it's not that sketch. It's this sketch. 1.5. I would love to see someone who knows what they're doing do this. So yeah, so what is the height from here to here? 3.7. What's the M4 socket head depth is 4, so we can't use that unless we wanted to increase that distance, but I feel like I'm kind of firm on that. What about M3? Is that right? If that's the case, I would because we just arbitrarily added that 3, right? So if I take this extrusion and add So it's 3. Where are my threaded inserts at? I think my threaded inserts are out. But if we could find an M3, because that would be the better way to install this. I mean, it's so annoying to have to use a nut and a bolt. Let's see if he uses a nut and a bolt. How does he install though? Yeah, so he did all the assembly here. Did he already have that installed, or did he put that together earlier? Yeah, see that?
I printed a small piece of plastic which can accommodate the sensor like this, and then I have this kind of standouts, or I don't know how to call them, to provide the proper distance between the back of the stepper motor and the surface of this chip. So then this is put together. So we assembled it, and then this is screwed on the back panel. And actually, I will disassemble it right now just to show you how it works. So I just used 2 screws to fix everything, and then 2 other screws to fix the sensor to the plastic plate. And then I will disassemble this. And now you can see this is the new version of plastic.
Yeah, see, I don't like that.
So this is how the sensor.
I would rather just go in. Okay. So yeah, so we're gonna do that. I'm gonna go get the threaded inserts. This thing's coming along, but it's coming along like not that fast. Okay. So yeah, let's just see what we have. It would be so sick, dude, if I could just if I could manage my part library, like a personal part library, and I could just say like okay, but this is the thing. Okay, so now yeah, we're getting to where we need to. Okay. So we got these holes here. So we don't want to make these holes the same. We could use. Do we even have M2? Where are my nuts and bolts? They're out there. I'm not gonna go get them. So annoying. Okay. Okay. Where are we at with this? We're just gonna use this. We're gonna use M3 by 4 by 5. So I forget exactly. I'm pretty sure the depth is 4, so we need to make the wall 4. So we're gonna say on this, change this to 4. Okay, so now the thickness between here is 4 millimeters. Great. And now we just need to make the, did we sketch this already? Oh, but now we need to sketch. I thought I had something. Wait, what? Where did that, oh wait, hold on. Wait, where did that? What the hell happened? I thought I swear to God I did do this. Fine, I don't really care. So we're gonna sketch on here. We're gonna make a rectangle. We're gonna make it AS. Oh gosh. Oh gosh. AS width. Wait a minute. Oh, I guess we didn't do this. Okay, so we need to go back to this extrusion, this sketch. So we made this 27. Wait, what? Why am I so confused? Okay. What's the thickness from here to here? It's 1. So let's just make... Okay. Sketch on here. 23 by 23. Circle here. I swear to God I did this. I don't remember what... Oi, oi, oi. Oi, oi, oi. Oi, oi, oi. Actually, if I had a CAD professionally, I think I would kill myself. If I had to use these fucking CAD tools all day, every day, I would end my life. Because they're just so bad. You know what I would really do? If I had to use these PCB designing tools every day, I would be up the wall. They're so insanely bad. It's just like, do I even want to live? So do you want to keep this open? It was 3.75, I remember it. Okay. All right. So, but that's, yeah, so okay, so now we're at where we need to go. So this needs to be 4.8. Or wait, we're going to say M3 threaded insert hole diam. There we go. Okay, now we're going to extrude this to the bottom. Oh, but we need some more geometry, right? We want to add the spaces. Okay, so let's keep going. So we need to add so this is going to go in like that. So we need to add those rectangles. So this one is going to be 4 times 2.54. This is going to be 3 times... Oh, but we want to actually add some clearance there for sure. So wait, so let's just add 1 onto that. So 3 times 2.54 plus 1 millimeter. Dude, the unit incompatible. I wish there was a setting. If no one watches these, but if anyone knows of a setting, comment, please. Tell me how to fix my life. Okay, so then what did we say here? Oh wait, but we want some more. Okay, so on the width here, we're gonna make this 3. 3. See, why can it do type inference there, but it can't just like... Okay. So we want so from here to here is 3.8. So we want wait, and what is this line width? This is 2.54. So we actually are going to make this 2.54 plus 1. So we're going to make this 2.54 plus 1. 2.54 plus 1. Okay, and then what we're going to say is this is going to be 3.8 plus 0.5. Wait. Yeah, maybe that's right. 3. Wait. Minus 0.5. Whoa. For real? Oh wait, no, I think it's just because of No, yeah, that's no good. Damn it. All right, let me go see if I don't think there's any M2s in my thing. Do I buy parts or do I... This is always the dilemma. It literally has to hold no mass and will have no forces on it. Whatever. Okay, so we want to take this, this, and this and extrude it. Remove up to next. Oh wait, no, but we have to fix that because we can't do this. We need to do that separately. So we need to now take that, go here, select this, extrude this, remove up to next, slow, 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 slow. Then we can do a circular pattern of a feature. You just so much clicking around. How can you even live like this? There we go. So is this right? His looks different, right? He adds a lot more room. I think I'm gonna print it on this face. No, I don't know. I don't know how I'm gonna print this. So very weird part. We could just take this and extrude it up to here. That makes it a little bit easier. Okay. Yeah, so I'm gonna do that. I'm just gonna whoa. Why does this have so much more room? I remember mine had that too. So, okay, so the plan is to use an M3. And we're just gonna use nuts. All right, let's print it. I'm good with this. Probably end the stream here, unfortunately, because it's probably gonna be a I don't know how long of a print. Presumably decently long. Okay. Jeez. Hustle and grind, bro. I'm on my grind. I'm on my fucking grind, bro. Downloads, encoder mount. Okay, we want to enable supports. I'm gonna slice this bitch. Why are there supports there? Goofy ass supports, brother. Goofy ass supports. Okay. $30. Is there anything else? Yeah, so it's gonna sit on its side. It's gonna lean over because I'm too lazy to fix that. Honestly, it would have been a matter of just taking this face, extrude, and like remove like 3. Like I'm pretty sure that's literally the extent to. Look at that. Wait, that's so weird. Wait, why did that happen? Oh, because it doesn't like do a full cut. We could just delete that body. Let's redo. And let's just take this body and just delete it. Oh, great. Well, presumably you could just export this body and it's no problem. So then you would have a face where it sits flush. Whatever. We already hit print. All right, because I'm really focused. I really want to just get to the software and the PID control because it'll be so cool to have like a like you mess with it and then it goes to its absolute position. Like I'm very excited to play with that. Uh, but yeah, so that's that. Oh, weak ass stream. What else is there? So the next steps here are we are going to fix this design, attach it to both. And I don't think there's any clearance issues because we really have a lot of room. We're gonna attach it to both motors on the. Unfortunately, though, we are like running out of pins on the soldered breadboard. I think I am finally ready to pull the trigger, and we're gonna redo the schematic, add the make sure that the pins work to have everything as it is, but then with the encoders. So we need 4 extra pins, and they need to be on 2 different I2C lines. I'm pretty sure I can make it work, but I don't want to like. Anyways, the point is, I'm finally ready to buy my first PCBs, and we're gonna see them catch on fire or whatever because I don't know how much current they can really handle, but it'll be really cool to do that. And then maybe I guess design a little enclosure for the electronics. Um, you know what? I can do a little bit of an unboxing. I've been meaning to do this because it's just been sitting in our hallway. I'm gonna go get my filament and we are going to unbox it and shelf it. Shipment. Okay, so the other thing that I want to do is I want to. So wait, we'll get to it because. Wait, let me do this properly. Unboxing. Okay, so the first thing we got here is I spent way too much on this, but this is the complete hot end assembly. So it's a backup in case things start to be weird again. There's that. Comes with the screws too. That's nice. So there's that. We're gonna put that in the shed. This is garbage. Okay. Then we have two more. We have two more hot ends. I bought them all because I had to collect them all. Just how I am. Played a little too much Pokemon. So we got the .8. It's not gonna focus. I got the .8, and then here we go. I got the .6 too. And the cool thing is that some of the filaments that Bamboo sells only work with the .8 and the .6, so that'll be nice to have. Okay. Then I have filament, blue PLA, black PLA, blue-gray PLA, orange PLA, green PLA. So just stocking up because you can never really have too much PLA. Okay, and then here is the filament that I am extremely excited for. That's a good box. I'm going to keep that box. You know, when you get a good box, hold on to it. This is Bamboo's polycarbonate. It's transparent. So we're going to be trying to make some light fixtures with this. We're going to put some smart bulbs and some designs and try to make something, fun. So I'm super excited for this. What I'm going to do is I'm going to do a test of rectangles, and I'm going to put and we're going to just see how much light comes through at well, maybe we'll make little cups or something like that. But we'll come up with some test part, and we can vary the thickness of it and see how the light changes when it shines through it. And I'm going to do 2 runs. First, I'm going to do 1 run where I just ordered it from them and didn't dry it out, because it recommends you dry it out. I'm not gonna open this yet, but I'm gonna open it when I'm ready to do the test once we've designed the test part. So this will be cool. And then I'll do a comparison test where I'll dry it out. I'll spend the 12 hours to dry it out, and we'll see just how good this thing is. I'm excited for this, though. I'm really excited for this. Not because of its strength or anything, but just because it's transparent. So with that, I think that's going to be the stream. Yeah, I don't know what else we got, so let's call it here. I'm going to go eat.